Assalamualaikum and hi. So now we are going to look at the motion of charged particles in uniform magnetic field. So we are going to look at what is going to happen to the moving charged particles in the magnetic field as soon as it experiences the magnetic force. So consider a charged particles moving in a uniform magnetic field with its velocity perpendicular to the magnetic field. So let us assume the figure 19a, where we have uniform magnetic field here, and we have a positive charge moving perpendicular to the magnetic field as the magnetic field is into the page and the velocity is to the right of the page. They are perpendicular to each other. As the particle enter the region, it will experience a magnetic force. We have deduced this where you have a moving charge entering a magnetic field, you can experience magnetic force, which the force is perpendicular to the velocity of the particles. Okay, so the the force that we are going to experience is going to be perpendicular using the right hand palm rule. Hence, the direction of its velocity changes, but the magnetic force remain perpendicular to the velocity. Okay, let us look at the first part here, where the charge enter, as we can see, using your right hand palm rule. Point your four fingers to the right as the charge is moving to the right. It has motion to the right, and then the palm of your hand is going to face into the page as the magnetic field is pointing into the page. So from here we can deduce that the thumb is pointing upwards, which leads our charge, which was initially moving to the right under the influence of magnetic field into the page, is going to experience a magnetic force upward. This force is going to lead the charge to not move straight, however to make a circular turn here. As the charge reaches this particular point, it is expected to move upward as the velocity is in this direction. However, using the right hand palm rule, we are going to experience the magnetic force which is perpendicular to the velocity to the left of the page. This is going to lead our charge to continue to turn in a circular path rather than moving in the initial intended direction. The magnetic force FB makes the part of the particles in the the magnetic force FB makes the part of the particle is a circular as shown in the figure 19A, 19B and 19C and D. So it doesn't matter even if you change the sign of the charge. However, apa yang akan jadi adalah when you have velocity dan kita ada magnetic field, using your right hand palm rule, kita deduce the direction of force experience. Dekat sini sebab dia negative charge, daripada right hand palm rule, direction thumb yang kamu dapat tu kita flip sahaja, you're going to get the direction of force. Walaupun dia initially nak bergerak ke kanan, tapi sebab ada force tarik dia ke bawah, dia tidak akan terus bergerak ke kanan, tapi dia akan deviate daripada initial condition, which leads it to have a velocity that is going to change. However, the force is still perpendicular. Force ni kita masih guna right hand palm rule to determine. So for all these four cases, using the right hand palm rule, whenever a charge enters a uniform magnetic field, it is going to form a circular part disebabkan dia punya forces yang leads to the motion yang bulat itu. Since the part is circle, therefore the magnetic force FB contributes to the centripetal FC. Okay, kita ada belajar dalam semester 1, we have FC is equals to mv square over r, iaitu you are going to have force which is going to lead to the center of the circle, which causes your object to move in circular path. So dalam kes ini kita punya charge particle under the influence of magnetic field ini is going to experience force, magnetic force yang menyebabkan dia bergerak dalam bulatan. Okay, this bulatan is very similar to the circular motion. Therefore, we can conclude that the centripetal force which leads to the circular motion adalah due to the magnetic force itu. So we can equate magnetic force is equals to FC, where magnetic force is QVB sine theta, and theta here is the angle between V and B. As we have mentioned here, the velocity and the magnetic field are perpendicular, sine 90 dapat 1. So FB kita is QVB sahaja. And we equate to FC, which is mv squared over r. And then you simplify your equation, you can get the radius of that circular part the object is making. Okay, charge yang kita ada ini akan membentuk bulatan. Bulatan ini akan mempunyai radius. Radius bulatan ini adalah mv, iaitu mass of the charge, multiply with the velocity of the charge, divided by the magnetic field, multiply with the magnitude of the charge. Okay, next adalah the period of the circular motion, T, mixed by the particles given by. So as the object is going to make a circle here, one complete cycle here gives you the period, where using the knowledge from our previous semester, V is equals to RV, for a motion in circular form, we are going to have velocity is equals to radius multiplied with the omega, where omega is 2 pi over T. So we are going to substitute this into here and end up with equation V is equals to 2 pi R over T. Rearrange, make your T as a subject. T akan sama dengan 2 pi R over velocity. Di mana tadi kita dah cakap all this charged particle is going to make a circle with a radius given by mv over bq. So kita substitute R kita sebagai mv over bq dekat sini, and you will end up with a new equation for your period. Period for the charged particles to move in the uniform magnetic field to complete one cycle adalah sebanyak 2 pi mass of the charge divided by the magnetic field multiply with the charge of the magnitude of the charge. Whereas the frequency that the charged particle is going to move is with F is equals to 1 over T. Alright.